Alright, let's look at the homework 3.4, problem number 3. Alright, so let's do this normal window problem. Alright, so parameter is limited to 22 feet. So we have, let's see, so we have a x plus, so that's the base, and the side is 2y. And here, this arc part is going to be, let's see, 1/2 of 2 pi r. So it's going to be pi r. R in this case is x over 2. All right, and this is equal to 22 feet, right? Then I'm going to just simplify a bit. So this is going to be, let's see, so this is x. So I'm gonna combine those x terms. So you have a 1x here and a plus pi over 2x, and then you have plus 2y is equal to 22. Right? I'm gonna solve this equation for y. So let's see. I'm gonna move this term right here over to the other side, right? So we get so we subtract 1 plus pi over 2x. So you have a 2y is equal to 22 minus 1 plus pi over 2x. Then divide through by 2. So divide through by 2. So y is equal to 11 minus 1 divided by 2 is 1/2 plus pi over 2 divided by 2 is pi over 4 x. Right? Then we want to maximize this area. So area is going to be, so the bottom part is x times y, so base times height, plus top half, let's see, the semicircle part is going to be 1/2 pi r squared. Radius is x over 2 squared, right? So we already know that the y is 11 minus 1/2 plus pi over 4x. So I'm going to plug it in there. So we get, let's see, 11x minus 1/2 plus pi over 4 x squared plus let's see, so this is going to be pi over 8 x squared, right? Let's simplify a bit. So this is going to be equal to, right? So let's collect the x squared term. So it's going to be, this is a negative 1/2, right? So you have a positive pi over 8x squared and a negative pi over 4x squared. So it's going to be negative pi over 8x squared. Right, then you would have plus 11x. Right. So if you take the derivative, so a prime, think of it as a function of x. So this is going to be negative, right, multiplied by 2. So this is going to be 1 plus pi over 4 x squared. Right, let's see, then plus 11. Right, or actually not square, because we took the derivative. Right, so we set that equal to 0 to find the critical number. Right, so first subtract 11, so you have negative 1 plus pi over 4 x is equal to negative 11. And then we can just divide through by negative 1 plus pi over 4. So you can see that x is equal to 11 over 1 plus pi over 4. Alright, I'm going to actually go ahead and multiply top and bottom by 4 so that we get 44 over 4 plus pi. Alright, so that's x. And if you want y, so there's a formula there. So you have a y is equal to 11 minus, right, so you have a 1/2 plus pi over 4. Then you're going to multiply by x, which is 44 over 4 plus pi. Alright, so this is going to be equal to, let's take the common denominator. So you have a 4 plus pi. So 11, so it's going to be 44 plus 11 pi. You're subtracting, let's see, so 44 so times 1/2 negative 22. And then, let's see, pi over 4 times 44, so it's going to be minus 11 pi. Alright, so you can cancel 11 pi minus 11 pi. So this will go, it will give you 22 over 4 plus pi. Alright, so we know that, let's see, original function a, this is a facing down parabola, and the maximum will occur at the vertex, so which is at 44 over 4 plus pi, comma 22 over 4 plus pi. Alright, so that's going to be the dimensions that produces the maximum area. Alright, so let's type it in. So we got 44 over 4 plus pi and 22 over 4 plus pi. Alright, so let's check the answer. Submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.